Okay, so we're going to solve some more double angle equations. This is lesson N5-5. All right, so as we've seen in the past with sine of 2x, we can replace sine of 2x with 2 sine x cosine x. All right, and then we would try to get one side to equal 0, so easiest way to do that is subtract 1/2. And then we'd have 2 sine x cosine x minus 1/2 equals 0. And at this point, we should factor. But I don't know how to factor this. In fact, I don't believe it will factor. So I've got to come up with another way of doing this. All right, so this is just not going to happen. Okay, so I'm going to start over, and I've got sine of 2x equals 1/2. Now, okay, so I know that on the unit circle that we had a value of 1/2 for sine. Okay, and that happened at pi over 6. Right, we would see that the y value was 1/2. And over here at 5 pi over 6, we also saw that the y value was 1/2. And that's what we needed for sine, y over r. Okay, so I've got those two places where that happens. Okay, but that's for sine of theta, right? This is really saying like two of those. So how do I deal with that? Well, I'm going to suggest that since x is located between 0 and 2 pi, then 2x would be located in twice that range. So if we multiplied both of these by 2, we'd have 0 to 4 pi. Okay, so 2x would occur at pi over 6 because that's in that range, and 5 pi over 6. But we would also need to add 2 pi to it because we're going once more around the circle. So that would be at pi over 6 plus 2 pi. And we'd also have another at 5 pi over 6 plus 2 pi. Okay, so I'm going to clean that up a little bit and say that 2x would be occur at pi over 6, 5 pi over 6. Add these two together and I get 13 pi over 6. And I add these two together and I get 17 pi over 6. Okay. But that was 2x. So how do I get rid of that 2? Well, it's multiplying, so I would divide. So if I divide all of these by 2, it would be the same as multiplying by 1/2. So x would equal pi over 6 times 1/2, 5 pi over 6 times 1/2, 13 pi over 6 times 1/2, and 17 pi over 6 times 1/2, which simplifies to pi over 12, 5 pi over 12, 13 pi over 12, and 17 pi over 12. And those are all in our range of 0 to 2 pi. Excuse me, our domain. Okay. All right, let's take a look at another one. Sine of 2x. I'm going to start off the same way I did this one. That would be 2 sine x cosine x equals 0. Well, those are all factors. 2 times sine times cosine. So that means 2 would equal 0, which we know that will never happen, so that's extraneous. Sine x would equal 0, which we know happens at 0, 2 pi, and 2 pi. And then cosine x would equal 0, and that would occur at pi over 2 and 3 pi over 2. Okay, so we put that all together, and our solutions would be 0, pi over 2, pi, 3 pi over 2, and 2 pi. But just out of curiosity, would it work with our new method? Okay, so this time 2x, right, still going to occur from 0 to 2 pi, right? So 2x equals 0. Well, sine equals 0 at 0, pi, and 2 pi. And then we would need to add 2 pi to go the second time around the circle. So pi plus 2 pi and 2 pi plus 2 pi. And some of you might be asking, why don't you do 0 plus 2 pi? Well, that would bring us to 2 pi, so we already have that one accounted for. Okay, so simplifying that, that would be 2x equals 0, pi, 2 pi, 3 pi, and 4 pi. And then we divide by 2. Divide all of those by 2, and we get that x equals 0, pi over 2, pi, 3 pi over 2, and 2 pi. So we get the same answer regardless. Either method would be satisfactory. Okay. You don't have to work it twice. Once will be sufficient. Okay. All right, moving on. Number 3, sine x cosine x equals negative 1/2. All right, well, this is not even an identity. If I bring this over to the other side to make it equal 0, that's just a mess. Okay, so thinking about it a little bit, we had something like this before where we had sine x cosine x, and we said we could rewrite that as 1/2 times 2 sine x cosine x. That would be equivalent. Okay, because 1/2 times 2 is 1, which was what we started with. Okay, so I'm looking at that, and this I could write now as sine 2x, and I want to get it by itself, so if I divide it by 1/2, okay, I'd have sine 2x equals negative 1. And I know that on my unit circle, right, negative 1 occurs for sine at 3 pi over 2. Okay, so if I use the method we did on the front where we're going from 0 to 2 pi, we then go multiply by 2, so we go 0 to 4 pi. Then I know that 2x will occur at 3 pi over 2 and 2 pi plus 3 pi over 2, which would be 3 pi over 2 and 7 pi over 2. Right? And then if I divide everything by 2 or multiply times 1/2, which I would prefer, okay, we get x equals 3 pi over 4 and 7 pi over 4. Okay. All right. Take a look at number 4 on our example sheet. Number 4, sine of x over 2 equals square root of 3 over 2. Okay. Now, I'm looking at that and I'm like, that looks really weird. But remember, x over 2 would be the same thing as 1/2 x. Okay. So now, this time instead of 2x, I have 1/2 x. So before, where I had my domain going from 0 to 2 pi, about 1/2. So I get that my new domain would be 0 to pi. Okay. So now I'm looking for where is the square root of 3 over 2, the answer to sine theta on the unit circle. And I know that it is in this quadrant, right? B square root of 3 over 2 occurs at pi over 3. And in this quadrant, we'd also get square root of 3 over 2, and that would be occurring at 2 pi over 3. Okay. So, similar to our others, we will say that 1/2 x equals pi over 3 and 2 pi over 3. And then to get rid of, or to remove the 1/2, we would need to multiply by 2. So x would be 2 pi over 3 and 4 pi over 3. All right, we've got one more. Cosine of 2x equals sine x. I think I'm just going to stick with the tried and true, replace with the identity, and I'm going to choose 1 minus 2 sine squared x as the identity. I have two others, but since this is sine, I think that would make the most sense. Okay. All right, so I'm going to move everything over to the right-hand side. So I've got a 2 sine squared x plus sine x minus 1. And that would factor to 2 sine x minus 1 and sine x plus 1. So we know that 2 sine x minus 1 equals 0 and sine x plus 1 equals 0. So sine x equals 1/2. Sine x equals -1. We've already seen earlier that sine of theta on the unit circle at 1/2 occurs at pi over 6 and 5 pi over 6. And then -1 occurred at 3 pi over 2. Okay, going back to my original, cosine versus sine, there's not any undefined spots, so x will be pi over 6, 5 pi over 6, and 3 pi over 2. Okay, get busy. Oh, wait, I have one little thing I want to talk to you guys about. See, on your homework assignment, this is from N5-5. You have this problem with 3x, and you know how I feel about when we don't do examples, that have something to do, that are unusual, and then they show up on the worksheet. Okay, so we're going to approach this one similarly to the last ones. We're going to change our range. We're going to multiply by 3, right? Okay, so we're going from 3x to 6 pi. Okay, so I'm looking at that, and I know that sine of theta is 1 on the unit circle. That will occur at pi over 2. Yeah. Okay. And then we're going to go around the circle 2 more times. So we're going to say 2 pi plus pi over 2. And we're also going to say 4 pi plus pi over 2. Okay? All right, because once around the circle we got to 2 pi, second time we got to 4 pi, and the next time around we'd end up at 6 pi. Okay, so simplifying that, that's going to be pi over 2. That's going to be 5 pi over 2. And that would be 9 pi over 2. Okay, so if we divide by 3, okay, we end up with x equals pi over 6, 5 pi over 6, and 9 pi over 6. But we probably would not ever see 9 pi over 6 because that'll reduce. So x equals pi over 6, 5 pi over 6, and 3 pi over 2. Okay, now go get busy on your homework.